Okay, so chapter 6.7 gives us this word problem. The population of a fish farm in t years is modeled by the equation P of t equals 1600 over 1 plus 3 times e to the negative 5 times t. So part A asks us, what is the initial population? So initial population means, what is the population when t equals 0? So we're going to plug in 0 for t. Then we get 1600 on top over 1 plus 3 times e to the negative 5.5 times 0. So negative 0.5 times 0 is just 0, and e to the 0 is going to give us 1. So this term becomes 1. So this simplifies to 1600 over 1 plus 3, which is 1600 over 4. So our initial population is 400 fish. That's part A. Then part B asks, what is the doubling time for the population? And round to the nearest tenth. So doubling time means if our initial population was 400, we want to find what t value gives us 800 fish, because 800 is twice. So we have 800 equals this 1600 over all of this from our function. Then if we multiply both sides by this expression here, then we get 800 times 1 plus 3e, and then it goes away on this side. And then we can divide by 800 both sides. So that goes away. Then we get this 1 plus 3e to negative 0.5t equals 2. Then we subtract 1 from both sides, get 3e to the negative 0.5t equals 1, and then divide by 3 and take the ln of both sides. So then we get negative 0.5t equals ln of 1/3. So t equals ln of 1/3 divided by negative 0.5. And then when we plug this into the calculator, we get about 2.2, and that's rounded to the nearest tenth. So after 2.2 years, the population is going to double. And then part 3 says, what will the population be after 2 years? So this one is more straightforward. All we have to do is plug in t equals 2. So we have p of 2 or in this case, t is 2. And then if we plug this into the calculator and we round it, we're going to get about 761. So after 2 years, there's going to be 761 fish. Okay, then part D says, how long will it take for the population to reach 1,325? So how long, which means we're solving for t again. And this time the population is going to be 1325. So 1325 equals our function, and we're going to be solving for t. Then we can rearrange this equation and get 1 plus 3e and all that equals 1600 divided by 1325. Then from here we just want to solve for t. So then we can subtract 1 from both sides. Then we get 3e to negative 0.5t equals all this minus 1. And then we can do both sides divided by 3. So all this divided by 3. And then take the natural log. So we have negative 0.5t equals all this minus 1 all over 3, the natural log of all this. And then we can just divide both sides by negative 0.5. So if we plug all of this into the calculator, and we could have done that step by step, or what I just did was simplified and solved for t and then plugged the whole thing in the calculator in the end. But either way, when we get the answer, we're going to round it and it becomes about 5.3 years. So around 5.3 years, the population will be 1,325. Then the last part of the question asks us, what is the carrying capacity for the fish population? And with functions like this, what happens is it grows exponentially and then it levels off because it can't just approach infinity. So what we can do is have the equation here, P of t equals 1600 all over 1 plus 3 e negative 5t. Okay, so at this point, we want to ask, as t approaches infinity, or as t gets bigger and bigger, what happens to this function? Well, as t gets bigger and bigger, this negative 0.5 times t is going to get bigger and bigger, but it's going to be a negative. So this e approaches 0 as t approaches infinity. So if this eventually becomes 0 as our t gets bigger and bigger, then 3 times 0 is just 0. So we have 1600 over 1 plus 0. And this just simplifies to 1600. So essentially what this means is, as t approaches infinity, as time goes on, our population is going to level out to 1600 fish. So if we look at this on a graph where our x-axis is going to be our time in years, and then our y-axis is our population, we see that the graph increases and continues to increase, and then it starts to level off, and it has a horizontal asymptote at 1600. It never actually touches 1600, it just approaches 1600 as our time goes on and on.